So
my silly camera thing. Although I don't think it's going to pick up the board well.
So 1 hertz is 1,000 kilohertz.
So 1 hertz is 1,000 kilohertz. Does that sound right? From the way I'm saying it, no.
Yeah, I did until just now.
How many hertz are in a kilohertz? You're saying there's 1 hertz in a kilohertz? How many meters are in a kilometer?
Okay,
So
so,
it's 1,000 hertz.
1 in 1,000. So a hertz is smaller than in kilohertz.
Correct.
Okay, so 1,000 kilohertz is 1.
No,
1,000
1,000
hertz is 1
kilohertz.
kilohertz. Yes.
So do you see how this then becomes 660,000 hertz?
Yes.
Right?
Mm-hmm.
Now what is a hertz? A hertz is 1 hertz
The cycle.
is cycle per second. So we can rewrite this as 60 cycles per second. Or you don't have to put cycles even, but that's just the way to, it's weird to say that many thousand per second, but that's really what it is. It's basically in say this was 1 second long between here and here. And we had something happening, 660,000 times in that 1 second. That's the frequency. It's a very high frequency, right? As opposed to if I were to say 1 cycle per second, it would just be like that. Or actually that's wrong. That would be half a cycle. It would be like that. It's 1 cycle per second. So within 1 wavelength of, this is 1 wavelength, within that 1 wavelength you have 660,000. Okay?
Okay.
Cool. So, so this is 1/seconds. And
So hertz is on top now because we changed it to hertz, and now we're taking hertz to, what are we doing? Going to nanometers?
Well, I guess really this is our answer here. This is per second, right?
Okay.
So this is our frequency in seconds, 1/seconds, right?
Okay.
Let me just make sure that works out right. Yeah. Okay, so that's our frequency. What is the formula we're going to use ultimately to find the wavelength?
The c times the speed of light times.
Well, c is the speed of light, yeah. C. I gave you guys all these formulas.
C times wavelength times
Velocity?
velocity. Whatever the v is.
Sorry?
Frequency.
Frequency.
C equals lambda times frequency. Right? Is that the formula?
Yes.
That should be the formula that I've given you, hopefully. Can I see that?
You did. I just don't know how I would know to even use that one.
Well, this is, so to start out, these problems seem overwhelming, and you guys really have to get in the habit of writing down what is in the problem, what have they given you, and what are you looking for.
Right.
Then you go compare it to all of your formula sheets, and you say, which one of these have given me, the most amount of things and has something I'm looking for. And that's how you figure out what formula you're supposed to use.
Okay.
I mean, you really have to, that's breaking it down, that's what your mind will be doing, but, you'll be doing it naturally, but in the beginning you should really be writing it down. So let's just start from the beginning. So it says, a WFAN transmits the NY Giants game at a frequency of 660 kilohertz. Find the wavelength in nanometers. So, what are we given in this problem? We'll call it given.
We have the frequency in kilohertz.
Okay. What else?
That's it.
That's it. All right. So what are we looking for now?
We're looking for the wavelength in nanometers.
Okay. So then I would come. So what I would stop there. I'd go to my piece of paper. I'd write down frequency is this. Looking for
Yes. Now,
lambda.
with that being said, with the formula you have, we can divide the speed of light by
Because speed of light is a constant, so they
It's
don't have to
constant.
give
We
you
have- we
speed
know
of
that.
light.
divided by your frequency, and that's going
So
to give
let's
you your wavelength.
so now which of the formulas have frequency and wavelength in them from your little
Right, the CO, the one you
I guess I
you
gave
just
it back
had.
to you, right?
Yeah, well.
That's fine, you can have it. I have
okay.
another
I
one.
was gonna say, do you need it? Cause I kinda do need this.
No, I have it.
The
I'll
other
go
one,
make a
that-
copy.
I got it.
Okay.
the speed of light equals
So you say speed of light equals
wavelength
wavelength
times
frequency.
and then you just need to swing that over because we're looking for we're
We're
solving
looking for
this one.
this,
Yes.
so really you'd say
Speed of
this
light.
equals
Yes,
like
that's
that,
it.
right?
Yes.
Now, so this is where, so now I know this is what I have to do. I have to divide the speed of light by the frequency. However, what is the speed of light?
3 times 10 to the 8.
Meters per second.
That's the key. The units of that are key. So again, we're going to have here C equals, let's say 3 times 10 to the 8th meters per second. Now this is in meters per second. This is in kilohertz. We can't divide meters per second by kilohertz. So what do we have to do to our frequency?
We already did it. We did
We
it in
have to get it
seconds.
into seconds,
That's right,
which we've
yeah.
already done. But this is the way you would solve, this is the way you go about getting to this point. Now, I had started the problem just making the assumption that you guys knew that,
Uh-huh.
and I started converting, but
Okay.
I guess I should have gone back and been like, this is the way we should. So now we have seconds, we have meters, and we can solve for lambda.
Right.
So let's do this. You guys can write it out, or
You wouldn't convert it to nanometers first before you,
you can
solved?
do that. You can do that. I like to do it afterwards because then I get confused. So if you want to convert this to nanometers, you have to then, this is going to be huge. You know what I mean?
Right,
It's going to
it's
be
huge.
how many nanometers, meters, nanometers. How many nanometers are in 1 meter? 10 to the 9th
Mhm.
nanometers in 1 meter. It's going to be a really big number. I like to wait.
Okay.
But good. Yeah. Eventually we're going there.
454.5.
Sure. I don't know what the answer is.
Okay.
Okay, so that would be, let's assume that's right.
Okay.
400, what is that?
454.5.
What are the units?
Well, we're still in
Meters per
meters per
second.
second.
Meters. It can't be meters per second. What are the units of this?
My constant speed of light is meters per second, isn't it?
Yeah.
Okay,
and what is
over- Over per
Seconds.
second. So it's meter per second squared. Is that what
Well,
we're saying?
the same thing as dividing by 1 over seconds is the same thing as multiplying. This is also equivalent to doing times 1 over the reciprocal,
Okay.
right? This is the same thing as multiplying by the reciprocal of this.
Okay.
So this crosses off, you're just left with meters.
Okay.
Or doing rainbow math.
Okay.
It would be meters seconds over seconds. Seconds cross off, you're left with meters.
Okay.
And which makes sense because wavelength should not be a meters per second unit. That's like saying I'm 5 feet per second tall. Like, that doesn't make sense. You can't be 5 feet per second
So
tall,
every second you're 5 feet tall.
right?
Yeah.
Wavelength is a distance in one dimension. It has to
Mhm.
be just in meters, or some conversion of meters.
Okay. So now we got to take the 454.5 meters and we need to change it to nanometers.
So how do we do that?
Well, the nanometers is going to be I don't know what nano. I'm kind of like looking.
Nano.
Yeah.
What does nano mean? It sounds like the number.
Tiny.
It's a tiny number, but the prefix sounds like a number what?
9.
Yup. So now is it -9 or +9?
Meters is bigger than nanometers, so we have 454.5 meters.
Ignore this right now. I'm just talking about this conversion,
Yeah, it's gonna
nanometers
be-
and meters. I want to make this 1. So how many? The way you read that is how many nanometers are in 1 meter, or how many meters are in 1 nanometer.
There's 1
It's like saying
nanometer.
There's 1 nanometer
and
in
10 to
10 to
the
9.
9.
Negative 9.
10 to the negative 9
right.
meters.
Meters.
That's fine. You could write it that way.
Right.
Personally, that's weird for me to say. I like to say there's 10 to the 9 nanometers in 1 meter. There's that many nanometers in 1 meter.
Okay.
It's kind of like saying there's 12 inches in a foot, or 1 inch has, 1/12 feet. Like,
Yeah,
that's weird.
okay.
That's the way you're saying it. But that's fine if you know it that way. It'll work out.
That's the problem. I don't know it that way.
No, but that's the way you said it. That's the way you said
Right.
it. You said 10 to the minus 9, which is
Right.
correct. You said 1 nanometer has 10 to the minus 9 meters.
Right. Right.
Or
Or you can say 10 to the 9 meters has
1.
1 meter in
Right.
1 meter.
which shows you a little bit easier that nanometers are smaller and
Yes.
meters are larger.
And then when lo and behold, if you take 454.5 times 10 to the 9th, you're going to get a really large number. You're
Right.
saying that many tiny nanometers are in this, that many meters.
Okay,
Does that make sense?
it does.
So
Just-
if you were to work that out, well, what's the answer?
it's 4.5 times 10 to the 11th.
Correct. Nanometers.
Yes.
Yes. Alternatively, a quick way to do this, not a quick way, but if you're really understanding how to do conversions and stuff like that, how many nanometers I won't even go there, forget it. That's just going to confuse you guys. Let's just leave it at that. Okay, so that wasn't too bad. It was the idea of converting the units that got you.
Right.